She can't believe she is doing this. She is parasailing over the ocean. She has always felt at home near the ocean, but this is a whole new perspective. Down below, she sees the turquoise water, the light brown sand, and the breaking waves. Click the highlighted areas to discover more. When done, click the next arrow to take a closer look at solutions and see some examples. Meredith thinks about the water she's flying over. She can almost taste the salt in the air. Salt dissolves in water, and in the ocean, salt is equally dispersed in the water. The salt water in the ocean is a solution. Meredith clips herself into the harness. The clips are made of stainless steel. Stainless steel is steel that contains at least 10% chromium. Although stainless steel is a solid, it is also a solution because the elements that make it are equally distributed throughout the material. After parasailing, Meredith digs her toes into the sand. The waves move the sand around, and the water becomes sandy until the sand all sinks to the ocean floor. This sandy water is not a solution because the amount of sand is not the same throughout all the ocean water. There is more sand toward the bottom and in the shallow areas. Welcome to the lesson, Solutions. In this lesson, you'll learn what a solution is and what its properties are. You'll also find out about how physical factors, such as temperature or particle size, affect the properties of a solution. The vocabulary words for this lesson are solution, solute, solvent, concentration, and solubility. Click each word to find out more about it. Is it true that this metal spring toy is a solution? You might be surprised to learn that the answer is yes. The metal in this toy is a mixture of metals called an alloy. Alloys are examples of solutions that are solid at room temperature. Solids, liquids, and gases can be mixed together and sometimes mixed with each other to form solutions. Did you know that when you drink a glass of iced tea with lemon, you are drinking a solution? A solution is a mixture of two or more substances that are homogeneous or evenly spread throughout the solution. In fact, all solutions are homogeneous mixtures. Click each image to learn more about solutions. When you mix two substances together to form a solution, the particles of one substance spread evenly among the particles of the other. An example is rubbing alcohol, often used for preventing infections. In a solution of rubbing alcohol, water molecules spread evenly or homogeneously among isopropyl alcohol molecules. In a solution, the less plentiful substance is the solute, while the more plentiful is the solvent. Just think of it this way. You dissolve the solute into a solvent. If you were to add acetic acid, the solute, to a larger amount of water, the solvent, you would have a solution of vinegar. It's the acetic acid that gives vinegar its sour taste. Listen to the fizz when you open a bottle of soda. You're hearing carbon dioxide gas escaping from the liquid. Carbon dioxide, the solute, is dissolved in water, the solvent, to make a solution of carbonated water. Not all of the carbon dioxide escapes when you open the bottle. Some remains in solution, so the soda stays bubbly. This musical instrument is made from a solution called brass. Brass is formed mainly from copper and zinc. The amount of copper is around 66%, making copper the solvent. Sometimes many solutes are added to a solvent to form a complex solution. This is often true of alloys, in which many metals may be combined to form a solid solution. Many liquids are mixtures of different substances, but not all of them are solutions. Depending on the size of the solute particles, these mixtures can be solutions, colloids, or suspensions. Click the images to see an example of each. The flavored drink in the glass is a solution. Water is the solvent, and the powdered drink mix is the solute. In this solution, the drink mix dissolves into extremely small particles that are evenly distributed or homogenized among the water. These particles are too small to scatter light, so the solution is transparent. Milk is an example of a colloid. A colloid has many of the properties of a solution. In milk, the particles are spread evenly throughout the water to form a homogeneous mixture. But these particles are larger than the particles in a solution, so they cause light beams to scatter. This gives the colloid a cloudy appearance. Like solutions, colloids are not always in liquid form. Fog is a colloid made up of particles of water, vapor, and air. Gelatin is a colloid of solid particles in a gel. Colloid particles may be seen in a beam of light, such as dust in the air when a beam of sunlight shines through the air. The particles of fat in milk can also be seen with a beam of light. Tomato juice is neither a solution nor a colloid. It's a suspension. The particles in a suspension are much larger than those in a solution or a colloid. In fact, the particles in a suspension are often visible, as in the case of silt or clay particles suspended in water. Here you see soil particles suspended in water. Unlike solutions and colloids, suspensions are heterogeneous mixtures. This means that the particles in the suspension are large enough to be filtered out from the liquid of the suspension, or will separate out when left standing. You've learned about the differences between a solution, a colloid, and a suspension. Now, let's see what you remember. Identify the colloids among the items listed. That's right, gelatin is a colloid of solid particles in a liquid. Well done! Fog is a colloid made of liquid water droplets in a gas. Colloids are homogeneous mixtures with particles that are large enough to scatter light. A solution is also a homogeneous mixture, but with smaller particles than those in a colloid. Solutions are fairly transparent. A suspension is a heterogeneous mixture with much larger particles than those in a colloid. Particles in a suspension can be separated from the liquid. Suppose you make a solution by dissolving salt in a glass of water. How will the solution change as you add more and more salt? Is there a limit to how much salt the solution will hold? Click the images to see how adding more solute affects the solution. Begin with the dilute image and move clockwise until you have seen them all. Sugar is added to a beaker of water to make a solution. Since there isn't much sugar in the solution, the added sugar dissolves completely. That is, the concentration of solute in the solution is low. Concentration is the amount of solute dissolved in a given amount of solution. At low concentrations, the solution is dilute. As more sugar is added, the sugar concentration in the solution increases. Before, the solution was dilute. Now it's more concentrated. Some concentrated solutions dissolve more solute for a given amount of solvent. Some dissolve less. A solute's ability to dissolve in a solvent at a given temperature and pressure is called solubility. A third spoonful of sugar will not entirely dissolve. When, at a given temperature, a solution contains as much dissolved solute as it can, the solution is said to be saturated. When this happens, no more sugar dissolves, and all extra sugar sinks to the bottom. Most solutes will have greater solubility in water at higher temperatures, so the saturated solution from the previous image should not hold the same amount of dissolved sugar when it cools. But if the solution cools without being disturbed, the amount of sugar that was in the saturated hot solution remains in solution. The solution is now a supersaturated solution. A supersaturated solution temporarily holds more solute in solution than it would under normal conditions, but it's unstable. Once the solution is moved, the excess dissolved sugar comes out of solution and settles to the bottom of the cup. Some sugar remains dissolved in the cold solution, but it's now saturated for the lower temperature. Another example of a supersaturated solution is a rain cloud. Because supersaturated solutions are unstable, the supersaturated air cannot hold the excess water vapor at the lower temperature and pressure. Any disturbance will cause the excess water vapor to condense in the form of rain, hail, or snow. Recall that solubility is the ability of one substance to dissolve in another at a given temperature and pressure. Other factors affecting solubility are the surface area of the solute and the movement of the solvent. Click the images to learn more about how each of these physical properties relates to solubility. The temperature of a solution strongly affects solubility. For most solvents, an increase in temperature also improves the solubility of the solute. However, some solutes, such as calcium sulfate, dissolve better at lower water temperatures. Gases also dissolve better in liquids at lower temperatures. The air pressure above a solution affects the solubility of gaseous solutes. Recall the example of carbonated water. Carbonated beverages are bottled under pressure, so as to increase the solubility of carbon dioxide. Later, when the bottle is opened, the pressure above the solution decreases and some of the carbon dioxide bubbles off and escapes. Notice that the person is stirring sugar in a cup of hot tea. Stirring is another way to increase solubility. In general, stirring brings more of the solute into contact with the solvent. This increases the solubility of the solute in the solvent. Increasing the surface area of the solute is another way to increase contact between solute and solvent. So, cutting or crushing a solute increases the solute solubility. This is why drink mix is in a powdered form rather than in the form of a large solid cube. Look at these images. They show situations in which solubility will tend to either increase or decrease. Drag each image to the category labeled with the most likely result. You've learned about the differences between dilute and concentrated solutions. Look at the pictures. Which of these images shows the most dilute solution of lemon juice in tea? That's right. The lemon juice from this lemon has not been squeezed from the lemon yet, so the solution is still very dilute. Solutions can be dilute, concentrated, saturated, or supersaturated based on the amount of solute in the solvent. For the most dilute solution, lemon tea, the smallest amount of solute, lemon juice, is added to the solvent. You've learned that a solution is made up of at least one solute in the solvent. Suppose you have three items: sweetened iced tea, seltzer water, a type of carbonated water, and grass. How is each of these a solution? And what are the solute and solvent in each? Type your response in the space provided. Click OK when you're done. You've learned a lot about solutions. Let's review the main ideas from the lesson. A solution is a homogeneous mixture of two or more substances. In a solution, the particles of one substance are spread evenly among the particles of the other substance. Although many solutions are either solids and liquids or liquids and liquids, other combinations are also possible. Gas can be dissolved in a liquid to form a solution. Gases are easily mixed with other gases. Solids can be mixed homogeneously with other solids when both are molten to form a solid solution called an alloy. Solutions differ from two similar types of mixtures called colloids and suspensions. A colloid is a homogeneous mixture of two or more substances. but the particles mixed with the liquid are larger than those in the solution. A suspension is a heterogeneous mixture with very large particles that can be physically separated from the liquid. Temperature of the solvent, air pressure above the solution, surface area of the solute, and movement of the solution are all factors that affect solubility. Typically, an increase in temperature, solute surface area, and solution movement will increase solubility. For gas dissolved in liquid, an increase in pressure increases solubility. Now that you've finished this lesson, if you wish, you can go back and review any part of the lesson again.